So thanks everyone for being here. So I'm just going to talk for a few minutes about how our class at Georgia Tech has been really helping to contribute to the knowledge base, and also just how it really nicely kind of blends in with academic work and scholarship. So this is our class. It's been going, we've done it 3 times, and it is a core course for our astrobiology certificate graduate program at Georgia Tech. So every student that goes through our program is required to take this course. And as you can see, a major component of it is the science communication project. So this is where we contribute to the knowledge base. But we also have these weekly discussions where a student presents on a seminal paper. So you can see how this kind of really goes hand in hand. And these are some of the papers that we did this past year. And of course, they're seminal, so you probably recognize, we always do, for instance, the Stanley Miller paper, for instance, if you like that. So the way this assignment went, first of all, we spoke with our wonderful NASA Center for Life Detection colleagues, and they recommended us this time. We try to kind of have a different theme each semester, so I'm just going to focus on this past spring. We had the theme of Mars, and so we did the McKay 1996 paper, and then we did the Viking, 1970, whatever paper, okay? And so they read those 2 seminal papers in addition to all the other seminal papers they wrote. And this is really important, I think, for the students. The reason we make them do all these seminal papers is so they really understand the history, the deep history of this field, which I think we can agree is so important. Understanding how this field, if you went to the event last night, goes all the way back to, to the 50s and even before. And so understanding how, to each student, really seeing how the scholarship has grown through time, how they are really, building, standing on the shoulders of these giants, and how their work just builds from this timeline of papers and who all their academic ancestors were. This is kind of part and parcel of that process. So these are the assignments that we go through. So you can see we've kind of broken it up into a series of assignments. Basically, they read and understand the seminal papers. They tell us which one they're most interested in. They learn about the database. Meanwhile, they're having office hours the whole time with every week for NASA scientists, and as well as Graham made their time available for an hour for these students. They create annotated bibliographies with 3 pieces of pro and con evidence, as you saw. And then they group those evidence into pieces of evidence into pro and con arguments. We start learning about the hierarchies then between what is evidence, what is arguments, etc. What is prevalence, what is signal strength, all these things. So we talk a lot about that. They write background summary, compile, then they do peer review. So this is a really good practice with what is peer review and that whole process. Then they even do response to peer review. So that's super good practice too. They edit their contribution and they create an account and upload it and final presentation. So you can see it's a pretty involved process. And I'm happy to provide the full copy of the assignment if you'd like. So here's some of the contributions that our students with their names and pictures have made. You might recognize. So Elizabeth Corbin, Hank Rainwater, Kavita Matange, and Tatiana Gibson. Jordan McKay, Ben Zussman, Lily Turner, Emmy, and Jay. So they basically, our students have really kind of, and here is Claire, spelled wrong. I forgot the hell. I'm sorry, Claire. Can't spell my own student's name, first name. Claire and Katie have made, and so you can see our fingerprints are kind of all over this. We're pretty proud of that. And so every week they had office hours with Andro, Alfonso, Dave Demaray, and Svetlana and Graham, and that was really special. So some of them really kind of came every week and got just, you can imagine, basically four NASA scientists just you ask them any question and they just talk for an hour. And that was like, you can probably gain more knowledge then than ever. So it was really, really special. And then this is some of the feedback we got. This is Ben said, one of the coolest class projects I've ever worked on because there's a tangible result. We got a lot of feedback like that. And here's our happy students getting their certificates. So I'm happy to introduce now Claire, spelled correctly, Elbin, who is a Georgia Tech Ocean Science and Engineering PhD candidate and NSF GRFP fellow. And just got the astrobiology certificate and an astrobiology fellow. So I'm very happy to introduce Claire, who's going to tell you more about her specific contributions. Thank you.
Hi, everyone. So I'm Claire, and I got to participate in the spring 2022 section of this class. And so I'm just going to talk a little bit about my specific experience with it. So I focused on the Viking lander experiments of 1976, and this really focused on metabolism as a biosignature. So they did 4 main experiments, but what I focused on was the labeled release experiment, which is essentially where they were able to see when they were adding a radio-labeled carbon into this Martian soil, they actually saw release of this labeled carbon into the above air, which was very highly criticized and highly disputed whether or not it was a true positive. So the question that I really focused on for this course was, what is the prevalence of an abiotic signal in this experiment? And that's just sort of an example of if it was a biotic signal. This is the oxidation of formate. So this is a biological signal that they were inferring might be happening. But we're wondering here, okay, what are the abiotic prevalence? So it got cut off, but essentially formulating an argument from literature review of a seminal paper can feel like you're drowning, especially when you're looking at a paper this far back. It can be really difficult to know where to get started and what to focus on. So what really helped a lot was the NASA office hours. They were able to provide, as you said, you could, as Jen said, you can, mention a singular topic and they'll have just such a broad and depth of understanding and knowledge of the papers and review and just talk for hours. It's great. But 2 main points that were brought up to me that really helped me sort of hone in on this abiotic signal prevalence and the relevant papers for that criteria were perchlorate and the Atacama Desert. So that was really, really helpful because at that point I was able to start a more typical literature review process, keeping those in mind in these highly relevant papers, and then work on those pro and con arguments based on the evidence from literature. So this is assignment 7. So this is sort of towards the end of our semester where we started to compile our contributions into the correct format for the LDKB upload. And this was really helpful because up until this point, I hadn't even realized how much literature I had reviewed and how much I had really started to understand, abiotic prevalence of metabolism looking at Martian surfaces. So that was really cool that we had done all of this back work. I hadn't even realized it until we got to this assignment when it was just like, wow, I've done a lot. And it definitely would have been intimidating starting from this point. And then the peer review process, I really, really appreciated having this process because not only did we send peer review as like, oh, you should change this sentence, or oh, maybe you should shorten this part or expand here. We did really what is more journal submission style peer review, where you had paragraphs summarizing what you read, and then a point by point kind of a response to go through. And then so we sent that to each other, and then the second half of the peer review was going through these responses and saying, what did I edit, what did I add, and then having this corresponding document keeping track of all of this. So that was really fantastic. And I know other students have mentioned it, but I will also say it again. It's really cool at the end of a class to not just turn in what you think is a good piece of work, but to be able to upload it and see it and, send it to your parents and be like, look, this is what I'm doing. So that was really, really enjoyable, having something so tangible to contribute to. And personally, I worked a little bit harder on it, knowing anyone on the internet could access this with my name on it. And this is just kind of like how I thought about this class working. So the LDKB is, it starts off as very broad as this structure, and you go down to category and topic and everything, sort of centering on arguments and evidence. I feel like we kind of worked from the bottom up, where there's so much peer-reviewed literature on these seminal papers, and you just become more and more and more specific and kind of hone in on that argument and evidence as well. But yeah, that's it for me.